In this project, 3-year recidivism prediction in Iowa, we looked to build a model to accurately predict whether an offender will reoffend after their initial release from prison or other correctional facilities. The dataset used contained data from the US state of Iowa and whether offenders had committed a crime within 3 years of their initial release from prison. The dataset contained 26,020 individual offender records and 17 fields, ranging from the year that they were released, to the nature of their release, to personal details of the offender, the details of their initial crime, whether they returned to jail, and the details of their return to jail. For the reasons of our predictive model, we'll be using release type, the 3 personal details here, offense classification, offense subtype. So there are 6 predictive fields, and we will be predicting whether someone returns to prison. We will next take a look at the techniques used in our model, firstly starting with data pre-processing. In this, we made an attempt to classify the severity of crimes as an increasing integer scale from 1 to 7, as this would be an easier way for the model to view the data. Secondly, we made attempts to amalgamate certain racial groupings that shared similar features and had low counts of offenders. Here we see the American Indian or Alaska Native, Hispanic and non-Hispanic groupings, and it becomes a standard grouping without the Hispanic classification. We next balanced the dataset using the Smoke-Tomek lengths combination sampling technique. This technique uses a combination of undersampling and oversampling in order to get a consistent dataset for training the model on. It was decided to use extreme gradient boosting or XGBoost classification on our model. This is known to be a very powerful predictive technique. In this, decision trees are made and incorrectly predicted variables have their weights changed through multiple boosting rounds. Over time, the accuracy increases hugely and we get quite accurate results. Finally, hyperparameter tuning took place in order for our model to be as accurate as it could be. In this, hyperparameters such as the learning rate or the max depth of the tree structure were tuned using various options to ensure utmost accuracy. 3 Python scripts were prepared, 1 for the pre-processing of the data, 1 for the hyperparameter tuning of the extreme gradient boosting predictive model, and finally 1 for the application of this model and evaluation of its results. The primary measure for evaluation of the model was recall of offenders that did reoffend within 3 years of their release. A score of 66% was achieved for these offenders. For the grouping of offenders that did reoffend, a precision of 42% was achieved. This means that 58% of offenders were incorrectly classified as reoffenders while not actually reoffending. In terms of the precision of those that did not reoffend, a score of 76% was achieved, indicating quite high accuracy of this measure. Overall, an F1 score of 0.63 was achieved for Class 0 and 0.51 was achieved for Class 1. In the bottom right here, we see the ROC curve. The AUC score for the model was 0.65. In this table, we see an ordering of the importance of variables. We see that offense subtype, the type of offense that the offender initially commits, is the most important in dictating whether an offender recommits a crime. Overall, the results of the projects were satisfactory, although it is felt that better results could have been achieved by a larger dataset with more variables available.